This is an absolute greenfield project. It's not only greenfield for us, but I would say it's greenfield for the country as well.
Different people understand semiconductor differently, right?
Yes.
What is semiconductor? What do you guys do? What part of the value chain are you? Say at the age of 19, decide to do this and not be out partying.
So we won't be really going inside. We'll take a window tour.
Yeah.
So we won't wear the bunny suit. Typically when we go inside, we wear the bunny suits. Given the requirements, etc., we won't really be going inside.
Sure.
So these are all employee entrances. The entrance from where we came in is entrance for visitors and management. You may want to have a look at this. So on the left hand side, you have machines, which are the absolute first process. So when you look at a wafer, this wafer, as I said, is extremely thin. It is 750 to 800 microns.
Hello and welcome to Borderless Business. I'm your host Ronak, and today with me I have Varun, the CEO of Sahasra. And today we are in their facility which does semiconductor manufacturing, and we'll be talking about semiconductor and much more. So why don't we start? So where are we? What place is this? When was this set up?
Okay. So this is an absolute greenfield project.
Yeah.
It's not only greenfield for us, but I would say it's greenfield for the country as well. We had this land back in 2014 as part of one of the electronic manufacturing clusters, something which was set up by the central government. However, from 2014 till about 2020, we did not have a specific plan in place. And we were also working on plans that we can, now that we have the land, what can we put up here? And then in 2020, opportunity presented itself. That's when the first tranche of the PLIs started. And so we actually incorporated this company in July of 2020 during the thick of the pandemic. And so Sahasra Semiconductors was born then. We are currently located in Bhiwadi, which is in Rajasthan. However, Bhiwadi is very close to Haryana.
Yeah.
So we are just about half a kilometer away from the Haryana border.
Yeah.
So we're kind of bordering both the states, but yeah, very much in Bhiwadi, Rajasthan.
So how large is this space right now?
So in total, we have about 5 acres of land within this cluster. In these 5 acres, the Sahasra Semiconductor facility has 50% of the land, so about 2.5 acres. And the balance 2.5 acres, which is on the other side, belongs to our EMS facility, which is Sahasra Electronic Solutions Limited. And that facility, that business of electronics manufacturing has been there for the last 25 years.
Got it.
But the semiconductor, the EMS business, yeah. But the semiconductor thing is as I said, greenfield, new to us, new to the country, and we'll talk about more.
Brilliant. So semiconductor, right? Different people, maybe will move in.
Sure, absolutely.
So different people understand semiconductor differently, right?
Yes.
What is semiconductor? What do you guys do? What part of the value chain are you?
Right. So we are in this semiconductor domain. There are, I would say, 4 or 5 key players, right? Or let's say components to the entire ecosystem. So one of the components is the design ecosystem, the people who design these chips, right? The second is a layer of people who are called IDMs, who would design, but they would also manufacture, right? Now within that manufacturing umbrella,
These are the Intels of the world.
These are kind of the Intels, the Microns of the world, so they are IDMs, right? Where they own the foundries, they own the entire value chain to a large extent. However, I would say that as of today, IDMs are not being born. This was something of the past. Let's say 60, 70 years back when there were IDMs.
Pre-TSMC.
Kind of pre-TSMC, yes. And then the third are the TSMCs, who are the fabs, right? And so they are the ones who fabricate the wafer, right? And wafer could be silicon, it could be silicon carbide, it could be gallium nitride. But these are the silicon is the most well-known type of wafer. Now we fall in the fourth component, which are OSATs or ATMPs, where once the wafer comes out as an output, and this is not the crispy wafer that we talk about in terms of chips, but this is actual wafer, which is either 8-inch in dia or 12-inch in dia. And this silicon wafer, once it comes out, from the time that wafer comes to us as an OSAT or an ATMP, the entire journey it makes from a wafer to a device or to a package or to a chip, or, these are the common names. That process is called semiconductor packaging. and popularly known as OSAT or ATMP.
Okay.
Now,
is it?
OSAT stands for Outsourced Semiconductor Assembly and Test.
Okay.
And when that outsourced word comes, which means, let's say you are a design house and you designed a chip. Now, typically what happens is you go to a fab and you give them the design and they make your wafer based on that design. Now, once that wafer is prepared, then that wafer goes back to the design house. Then the design house would give it to an OSAT, someone like us, to process it, make it a device and get it back.
Got it.
So that's why it's outsourced semiconductor assembly and test. Now, what's the difference between ATMP and an OSAT? So the ATMP stands for Assembly, Test, Packaging and Marking.
Yeah.
The only difference really is that in an OSAT, you do not have the responsibility of buying the wafer.
Okay.
Okay.
Okay. The wafer comes to you from
the wafer comes to us from the client.
From the client.
From the client.
Yeah.
In an ATMP project, and that's why we call ourselves an ATMP and an OSAT, because in ATMP, you might be sourcing the wafer yourself because you may have contracted or worked with a IC design house for that particular chip.
Got it.
So why we are a combination of both, because there are some chips that we are packaging where we are doing the activity of an OSAT, and there are some other devices like our memory packages where it's an ATMP, where we source the wafer, we are responsible for the engineering information behind it, and then we come out with the package.
Got it.
So in terms of the packaging activity, they're both
the
same.
It's the liability in terms of
exactly
the cash
and
flow
how you manage the value chain.
Got it. Understood. Understood. Yeah. So the facility here, the manufacturing happens here? No.
Yeah. So just to give you a glimpse, we are in a facility whereby it's like you see a PIP, a picture in picture. So this is like a facility where we have beyond this particular wall, we have our clean room environment there.
Yeah.
So this downstairs and upstairs we have our office area.
Yeah.
So this building is basically divided into the mezzanine and the ground floor.
Yeah.
On the ground floor we have the entire packaging facility, and in terms of the mezzanine we have all the office and engineering areas.
Yeah.
And then on the other hand we also have on the mezzanine level we have the utilities.
Okay.
So because it's a clean room, there are a lot of utilities that are above the ceiling, where the air conditioning, the air circulation and all other utilities are installed over there.
Got it. And this clean room, right? I'm sure for a lot of uninformed sort of people, which was all of us before we entered into this space, which is why do we need a clean room?
So basically the idea is, everybody had heard of clean rooms in hospitals, pharmacies.
Yes.
In pharmacies one would understand because when you're making, let's say, tablets and drugs, you want to make sure that you're popping something which is absolutely clean.
Yeah.
Now what happens in the semiconductor world is that you really need to have cleanliness, because a very, very tiny particle of dust can create problems during the packaging process. And not only the packaging process, but during the fabrication process. So in fact, fabs, their clean rooms are far more superior than clean rooms of OSATs.
Yeah.
Now, once we go inside, we'll show it to you. Our clean room is divided into two. There is a class 100K and there's a class 10K.
Okay.
And so there are ISO norms based on which there are clean rooms starting, when I'm talking about class 100K, that's almost at the top of the pyramid. At the bottom of the pyramid. And then it goes up to class 10K, which we also have. And then that moves to class 1K, going up to class 100, class 1. So it's basically where the more and more cleanliness is there, is you are actually packaging or fabricating stuff where not even what you cannot even visibly look from your eye is not supposed to be there. It can create a short, because when you talk about something like a 2 nanometer, which is absolutely cutting edge, you can imagine the particle of dust is going to be above 2 nanometer. So if that 2 nanometer gets shorted, your entire wafer is gone.
And 2 nanometer, like for audience, would be like what, 10th of a size of a hair, or how tiny?
It's just about that. It's something which is absolutely not visible as well.
Yeah, fair.
Come, we'll move upstairs and then we'll also take you to the packaging floor.
Great. So you joined the business how far back?
Okay, so I basically joined the business in the year 2000.
Okay.
And this was when I was 19 years old.
So at the age of 19, decide to do this and not be out partying.
You know, I always tell everyone that I went to Sahasra University.
Yeah.
And that's where I've learnt everything.
Huh.
But actually, I think there's a point in time in life where everybody realizes at some point in time in life that you have to do something.
Yeah.
Okay, and I think it dawned upon me at 19.
Wow,
The situation and circumstances for me at that point of time were such that I think I realized that if I don't put in effort right now, I might lose the race. So Sahasra, in fact, in Sanskrit, means millennium.
Okay.
And we started the business in the year 2000, so it was the millennium year. And therefore, instead of calling it Millennium Electronics, we called it Sahasra Electronics.
Interesting. It's a very
and
cool
Sahasra stands for millennium in Sanskrit. So, that,
Interesting.
made a lot of sense for
Interesting.
us. So
you were here almost at day one.
Yes, I was in the business from day one.
Interesting.
In the Sahasra business. My father did have one company together with a couple of other partners, which he actually started his entrepreneurial journey in 1991. However, in 2000, he split ways with those partners. And so together with me together with him, we started Sahasra.
Amazing.
And we started from electronic component distribution, getting into manufacturing very quickly. And then today, 25 years hence, we are in semiconductor packaging now.
So maybe you can also walk us through the facility once. Like you were saying, you have clean rooms. This is your office floor. We just came up. So should we go down, see the facility first and then come back?
Absolutely, we can do that.
Brilliant. And so this facility right now, right? You were saying ATMP. So you work with global clients, Indian clients. What is it like?
So, and this is something which I'd love for people to understand. So, there is a conception, and I don't want to use the word misconception, but there's a conception that, when you're doing semiconductor, then you can just start and, everything should just happen. So, it's not really like that. It's going to be a very long drawn process. The fact that I mentioned at the start that semiconductor is greenfield not only for us but really for the country, right? And therefore, Honorable Prime Minister is himself and Honorable Minister Ashwini Vaishnavi is themselves, pushing the government to be able to move in the direction that how important semiconductor packaging is. Now, having said that, one has to understand that semiconductors have been available since the last 70 years.
Okay.
Right? India has not been part of that in terms of the manufacturing aspect of it. So, overnight, suddenly, let's say customers will not start buying from us.
Yeah.
There's an entire validation exercise that has to happen. And this validation exercise that has to happen with its own pace. While we all might be in a hurry for things to really take place, but it's not really going to happen just from that perspective because everybody has to go as per their procedure and steps.
And I'm guessing it's for us it's new, but globally it's a mature ecosystem.
It's a very, very mature ecosystem.
Yeah.
All our clients, right? They are global in certain aspects. They could be an Indian consumer of it, but they will be global because, let's say, some of the Indian customers who we do have, they are not buying it necessarily from us, but they're buying it from somebody else, which is a global buy.
Yeah.
So they all go through their procedures and systems to get the validation done. Now, an ATMP might be slightly different because there they get a finished product. They're not buying their wafer and giving it to us. In an OSAT, because they do that, they are more careful about the wafer they give because it costs money.
Yeah.
In the ATMP process, I'm responsible for that. So let's say if I were to destroy a wafer at my end and give them a final product, they don't really look at my yield. Which is very, very important for us. But from a OSAT perspective, you have to be concerned about your yield, but more than that about your customer's yield, because the wafer is the most expensive item in the entire packaging process.
Yeah.
Right?
Yeah.
We'll just take a break and where the
Yeah.
So we won't be really going inside. We'll take a window tour.
Yeah. Should
So
we remove the jackets?
Yeah, please do.
Yeah.
So we won't wear the bunny suits.
Yeah.
Typically, when we go inside, we wear the bunny suits.
Got it.
But given the requirements, etc., we won't really be going inside.
Sure, sure.
Please wear this.
Okay.
Okay. Put your hand on top of this.
Okay.
Meeta, you'll touch the card. Yeah.
Okay.
If the light turns green, that means you can move ahead.
Thank you.
So basically, this is an ESD gate.
Okay.
So what happens in ESD gate is that any kind of electrostatic charge, right? Again, very simple, talking about how when we comb hair and something sticks.
Yeah.
So any kind of electrostatic charge can damage integrated circuits in a very, very bad manner.
Yeah.
So to avoid that, we go through this gate so that we know that the body charge has been discharged.
Interesting.
Right?
Interesting.
So that's the idea.
So it is even like that sensitive.
It is very, very sensitive, extremely sensitive. And please do put your foot on that, because
Yes.
any level of dust that might be there
Yes.
will get rubbed off.
Yes. Yes.
So we're now in the air shower.
Huh.
So in the air shower, and we move all sides so that any dust that we might have on any side of the body,
आपको भी थोड़ा घूमना पड़ेगा.
that dust gets removed.
हाँ.
And again, the reason to go through the air shower is that any kind of dust that we might have on us as a person,
Yeah.
that dust gets removed.
Amazing.
Right?
It's like a person with an OCD built this space.
Yeah.
Essentially.
Now,
And you need to do that.
I'm glad you spoke about building this place, because I'd like to share. So when we came to the, when we started to build the facility, and today in 2025, there are several OSAT facilities that are being, spoken about and are coming up, and a lot of global expertise is also coming to India, and thanks to the likes of Microns and Tatas and all that. But when we started to construct the facility in 2021, and prior to that, we sat on the drawing board with the architect. There was really nobody in clean rooms then, or even telling us that how do we construct this facility? What should be the layout? Now we've had some experience, because we basically got into the ideas of setting up this facility in 2018. And that's because we were in the memory business right since 2016. And so this was a natural progression for us. So having said that, we had been to a few facilities worldwide, and we'd got some glimpses and experiences of what facilities we had seen. And so all of that knowledge is what we brought to the table, and through some partners and all of that.
Got it.
But I mean, Sahasra Semiconductors even today does not have any technology partner. Whatever we've built so far, we've built ourselves. And therefore...
that must have been extremely challenging, right?
Yes, extremely challenging, because it was during the pandemic period, so there were challenges.
All sorts of challenges.
There are all sorts of challenges. I mean, I think your episode will run for 4 hours if I start talking about that. But as a result, we had to just put all our thoughts to it. And ultimately, it's about logic. You have to, build your flow to the extent that, it goes as per the flow, based on how you
Sorry, I'll also ask you, what are we crossing? And
I'll come to that. So we're walking right to the, first step of the project, of the process. Along the way, as you see on the left, are also a couple of air showers.
Yeah, to all enter?
So these are all employee entrances. The entrance from where we came in is the entrance for visitors and management. And these entrances on the left are employee entrances, divided into male and female entry exit points.
Got it.
So that they are also able to have their own access.
Got it.
As you can see, one of the people there in the bunny suits, having probably exited the 10K area.
Got it.
So we are pretty much at the start of the process as such. And I think behind your cameraman is the storage area where we store all our incoming raw materials. So the incoming raw materials are stored in this area, and even the incoming storage is also class 100K.
Okay.
Because until unless it's stored in a clean environment, it cannot be really issued to manufacturing in a clean environment, right? So even the stores is a 100K area.
So I'm sure when all of this equipment is coming, it's coming globally.
Yeah.
How do you get it all through customs? Even there are spot checks and this
Yeah.
and that, right?
Yeah.
Because if it requires this level of sensitivity when it comes to storage and actually sort of the entire process being clean, wouldn't that be a challenge in itself?
Yeah, so a lot of the product that comes in sealed packaging, right? So because it comes in sealed packaging, therefore it is already secure and safe to the extent that it's not supposed to be opened, and it's kept under certain kind of locks so that it's not tampered with. The beauty about it is because everything is extremely small and light in nature, therefore everything comes by air, so we don't depend on sea shipments per se. And therefore, because a lot of people have asked us the question, why Bhiwadi? Well, there are multiple answers for that, and I'll come to that. However, one of the benefits is being close to the Delhi airport. So clearance of raw materials for us is a very easy task from that point of view. And because we've been in the manufacturing space for the last 25 years now, so our dedicated inbound and outbound logistics team, they work on clearance of these materials. So let me start from here, and I'll tell you in a very short way possible. So this is the entry to the class 10K, and class 10K again, as I said, is the clean room area. And I'll just show it to you from the window itself. Before we go to the window, so if you can just see here on the front, we have this arrow which shows that this is the front of the line process. So the process is divided into two, not only in terms of the clean room, 10K and 100K, but also in terms of the process itself. So FOL stands for front of the line, and this is where all the initial processes are done. And then when the device gets molded, and we'll come to that, then we start with the end of the line.
Got it.
Right?
Got it.
So if I just run you quick through this window, you may want to have a look at this. So on the left hand side, you have machines, which are the absolute first process.
Okay.
So when you look at a wafer, this wafer, as I said, is extremely thin. It is 750 to 800 microns. Okay. And when that wafer comes, it has to be obviously handled very, very carefully because it's a lot of dollars on that wafer.
Yeah.
So the 750 to 800 microns is reasonably thick that it can be handled. However, in these machines, which are what we call back grinding machines and dicing machines, so what we do is we grind this wafer so that the thickness comes down. Now, depending upon your total package thickness or your total device thickness, you do the grinding. Our current machines are capable to be able to do back grinding right up to 50 to 60 microns.
Okay. Okay.
And that is extremely thin.
Yeah.
So it can actually break very, very easily if it is mishandled or if it is not ground properly. And I'm telling it to you in a very simplistic form.
Yeah.
So once that wafer, in fact, the wafer, when you put it into the machine, the very first machine is a taping machine where you put a tape at the back of the wafer.
To help its rigidity.
To help its rigidity, because when the back grinding is happening, during that process, that you're thinning the wafer down.
Yeah.
So when you're thinning it, there's a possibility it might just break.
Yeah.
So therefore, to avoid that, the tape gives it rigidity. Thereafter, in the machine, it's an inline machine. De-taping happens, and then another tape gets added before dicing.
Okay.
And
dicing is cutting it.
Dicing is a process of basically cutting it. We have two types of dicers. We have what you call the mechanical saw, but we also have a laser dice.
Okay.
And so depending upon the package that you build, you have to use either of the processes.
Got it. And one thing you mentioned was this layer thing, right? What is it? How many layers and how does it work?
The layer in terms of the...
So you said you dice it as thin as possible, depending on how many layers you're going to stack.
Okay, so and for that we'll move to the next process. So what happens is that once you do the dicing, now this wafer, which seems to be like a single wafer, is actually not single. There are individual dies in between the wafer. Okay, so depending upon the die size, which could be 1 mm by 1 mm.
What is a die?
A die is the actual chip.
Okay.
Right? So this die is fabricated onto the wafer by the fab house. So TSMC or whoever it would be.
Got it.
And so that individual die is what will go inside a chip.
Got it.
So that die, once it's singulated by doing the dicing, now you might see there might be a wafer. If the die is really small, let's say 1 mm by 1 mm, you might have 70,000 dies in one wafer.
Got it.
And if the die is big, you might have only 1,000 dies in one wafer.
Got it.
So for example, the memory packaging that we do, there is about 1,024 die in one wafer, 12 inch. And we do the eSIM ICs that we do, there are about 60,000 die per wafer.
Got it.
So it depends. And so dicing is very critical.
Got it.
But coming to the layer stacking, so after you dice, now these dies are individual, and therefore they go into this next machine which is called the die bonder.
Got it.
In this die bonding machine, individual dies are now picked up from this wafer and they are placed on either a lead frame or a substrate. The substrate may be in the case of slightly more advanced packages, and all those packages will be anything where you're looking at, for example, memories, high-end CPUs, etc. And when you look at the eSIM ICs or SOPs, TSOPs, TSSOPs, QFPs, these are all on lead frames.
Got it.
So after we do the die bonding, there we can do die stacking as well. Okay, and these stacks could be as high as 4 layers, 8 or even 16 die stacks.
Got it.
Right?
Got it. And that die stack, for example, that gives, I mean, what does it achieve, right?
So it achieves two things. In the memory world, a lot of capacity can be built up.
Got it.
And within memory and non-memory world, you can also do a lot of compactness in one die.
Got it.
Sorry, in one package.
Got it.
So you can basically pack in a lot more power within that package.
Got it. And when people talk about this 5 nm, 2 nm, 10 nm, वो क्या है?
So the nm stands for nanometer,
Yeah.
and that practically is related to do with the fab, not an OSAT.
Okay.
However, that is related to the, in very layman terms, it is related to the line width, line spacing of the circuit that is on that die, on that
Okay.
individual die.
Got it.
Right? So let's say the SOP package that we're doing is actually 1000 nanometer.
Okay.
Right?
Okay.
And it's still being used.
Wow.
These LED driver ICs are going into lights, still being used. Right? However, the memory that we do, that could be 20 nanometer, 7 nanometer or less.
Got
It depends upon the technology at the wafer level.
Got it.
Right?
And for an OSAT and ATMP, it doesn't matter. You can take any chip.
It doesn't really matter.
Got
it
it.
doesn't really matter.
Got
right?
it.
Just to show you, so the last process of this particular front of the line, after the die bond, we have the wire bond.
Okay.
Okay, so once you place a die on this substrate or on the lead frame, now you have to connect that die to the substrate to create connections, electrical connections. So these are wire bonding machines. Again, these wires are 0.7 mil, 0.8 mil, 1 mil thick. So extremely thin wires, which like a 0.7 mil wire is almost impossible to see with the naked eye. Right? So the die bonding machines.
And that's why they have those sort of scopes that
Yes,
help them.
that's why you have the scope, so that you can see inside the scope and actually look at the bond pads where the bonding is happening.
Got it.
And then we have a lot of reliability equipment to validate that those bonds are actually correct, not correct.
And which are those lights then, I'm guessing? Those the lights that are there, the red, yellow and green? So that has nothing to do with this?
No, those are only indicating lights of the status of the machine.
Okay. Just
So green would mean that the machine is running, and orange would mean that it's on standby. Maybe a changeover is happening or something like that.
Got it. Understood.
Right?
Understood. And what I'm seeing is a large part of this movement from machine to machine here is manual. Is that global standard, or is there a lot more automation globally and we are still in the sort of...
So manual to the extent that these wafers and these lead frames, they move in what we call cassettes.
Okay.
In cassettes is how do we transport them, but yes, we practically move them manually. However, in let's say global OSATs, depending upon their scale and size, there are two methodologies. One is movement via AGVs. So what they call automatic guided vehicles. So these are robots basically which will carry your product. Or you might also have which is typical of fabs, what you call OHPs, overhead movement systems, right? So now we're coming to the class 100K. So this is the end of the line.
Got it.
Here we have our molding machines. So from the point of view of packaging, in the molding machine, we package the particular product, right? And 100K is an area where you have slightly more leniency in terms of the clean room.
Yeah, that's
so that's why it's called 100K. That's why we have stepped in here.
Yeah.
So we have 2 molding machines whereby we do the molding. Now, once you do the wire bond, that package is still very sensitive.
Yeah.
To reduce the sensitivity, to reduce any kind of mechanical stress, any kind of environmental impact is why basically molding is done.
Got it.
Right? So these molding machines are basically used for that purpose. So you can mold any kind of package and you have to have mold tools which is based on the package that you're going to build.
Got it. Got it. And so from here, this is the end of the line, or
so this is the first stage of the end of the line. Now we have a door at the end where is through we do the pass of the material from this door, so that we go from this process to the other process.
Got it.
But we'll just do a walk from the gallery.
Yeah.
So once you finish the molding process, then basically we come to the second half of the end of the line. I'll actually show it from outside because there are a lot more machines here.
Yeah.
So now, depending upon the package you are building.
Yeah.
Now, because we do micro SDs, so in micro SDs, as a lot of people may have seen, there is a particular shape to it. So due to that shape, we have one of these machines which is known as a laser curve cutting machine.
Got it.
And the second is a laser marking machine. So the laser marking is the one on which you might be able to find made in India. Or let's say on an IC you might have the brand name, let's say it's Micron for example, or it's SanDisk, or it's one of those brands. So that marking happens on the laser marking machine. However, the profile happens on the laser curve cutting machine.
Got it.
Right? So these are the 2 primary machines at this process.
So shaping and etching, more or less.
Shaping and I still wouldn't call laser and etching.
Yeah, sure.
But it's a laser process whereby you do a marking. Yes, it kind of etches into the mold compound, and that's how the name is written.
Got it.
I think we'll have a better view from this side.
So these are the things that you're making, is it?
Yes, so these are micro SD cards that we build, right? And so the entire terminology is put here for training purposes and also for customer understanding. So there are different types of micro SD cards in terms of their capacity, read-write capacity, in terms of their speed, read-write speed, and also their class, that how much of capacity of images or videos they can store, how does the speed work. So they're divided into different categories.
And so which one do we do?
So we do a lot of these. We do, actually we start from class 10 onwards. So we do class 10, U1, U3, and we do different video class speeds, right from V10 to V90.
Got it.
Anything below this is much older generation, which we don't do anymore.
Got it. Got it.
And this is based on the SD standards, which is a body that is an international body. And so we are members of the SD Association. And we also pay a royalty fee to the SD Association for using these particular standards.
Got it. Right? And then who are our clients?
I'll just come to that. Just would like to finish the process. So once we are building these micro SDs.
This feels like, have you seen Severance? It's such a...
So when you're building micro SD packages, so those were the 2 machines right at the back, which are the machines with respect to laser marking and laser curve cutting. However, the other machines here, so on the right, when we're building leaded packages, okay, so leaded packages, we have to, within the electronics domain, people who would have knowledge will know that you have 8-pin, 16-pin, 24-pin packages. So to form that kind of lead in terms of making it a gull wing, making a J wing, etc. So these are trim, form, and singulation machines.
Got it.
So the packages, when it's molded, it's absolutely flat.
Yeah.
Okay, the leads are flat. So then trimming it so that it gets broken away from the lead frame, forming it to the kind of size you want to form it, and then singulating it from the entire lead frame is what is done on these machines.
Got it.
The one on the left here is called package dicing.
Okay.
So when we have lead-less packages,
Okay.
they don't go on the trim form machines.
Got it.
They go on the package dicing machine.
Got
So on the package dicing machine, we do packages like QFN, DFN, right? And then right in the center where we have this machine which has got a lot of mechanical parts in it, this is where the devices will go for testing, handling, visual checking, visual but via the machine, and then they get transferred to a tape and reel or a tube or to a tray. So this machine is connected with the tester at the back,
Got it.
which does testing. At the same time, it does it's called a handler. So it handles the devices at extremely high speed. You know, it can do something like 20,000 devices a day, right? And so at extremely high speed, and then it automatically packages it into the tape and reel package.
Understood. Understood. And that's the kind of stuff that you send to a...
That gets shipped out to a end client.
Got it.
Now, it depends upon the kind of product. Something might go in a tray, something might go in a tape and reel.
Got it.
So you spoke about kind of customers. So in the memory domain, we have, let me categorize it into 4 kind of customers. So one is we serve a lot of e-commerce companies. Internationally, our product is available on DigiKey, which is a pretty large e-commerce electronics.
That's your product.
That's our product, our brand. It's available at DigiKey, which is an electronics e-commerce platform. Then our product is also available on Amazon, so that's within India.
And what's it called?
That will go in the Amazon brand itself.
Okay. The Amazon brand product is got it.
Right. And the second category is where we have export customers. So, for example, we have Hama in Germany. We made an announcement also about that a few months back.
Yeah.
So we ship to Hama, and then they ship to their customers overseas. We exit from here. So what you saw was just about 1/3 of the facility.
Okay.
We have 2/3 of area available, fully furnished, ready to move in, what we call plug and play.
Yeah.
So once we start to scale up, then we have to just plug in the machines and switch on the lights, practically speaking.
Practically speaking.
So the balance area is exactly the way as you saw the initial area, other than the fact that it is lights are off and it's it's not being used.
Got it.
But otherwise the area is fully ready.
Got it. And so right now, what's our capacity and what's our utilization like?
So utilization as of this as of right now might be just about 10%.
Oh.
So the capacity that we have is making about 600 million units. This is based on single die, and this is based on let's say a 10 wire. There's a base pin there.
Yeah.
So 10 wire connection. That's the way we calculate it.
So yeah, you're telling me you measure capacity by the number of pins and.
Yeah. So this is based on a single die and based on 10 wire connections.
Got it.
So depending upon the kind of wire connections you have and the number of dies, the capacity might change.
Got it.
But this is one rough thumb rule. Coming back to the customers, so I gave you 2 categories.
Yeah.
The third is the export category, whereby we are also exporting to customers overseas. They could be in Mexico, they could be in the Middle East, they could be in South America, Southeast Asia. So that's the third category. And the fourth is what we call the B2B category. So we have several customers in India to whom we provide memory cards. These could be for drone applications, for cameras, right? And again, within cameras, different kind of cameras. You have CCTV cameras, you have dash cameras. Drones are cameras by themselves. So it depends upon what kind of application.
And these are basically that come fit with the device when you buy it?
No, not really. In fact, cameras never come fit with devices, with the cards.
Yeah.
So you have to have cards which people would buy from, let's say the open market, and therefore, or buy it from OEMs. And therefore, we are able to, be one of the vendors of choice of these camera companies to buy cards from us, bundle it together with their customer, their product, and give it to their customers, or there could be people just buying from retail, right? And retail could be e-commerce retail, or it could also be retail in terms of buying from regular retail stores.
Got it. And then you mentioned that you have 10% capacity utilization. So what's stopping you from like blowing up?
So it's a mix of 2-3 things. One is that the entire portfolio that is there in the memory world, we don't have the full portfolio yet.
Okay.
And so we are slowly developing products to be able to serve the full portfolio. So that's one. Because till you do not serve the full portfolio, you will not be able to scale up, one, because your customers may want a larger portfolio from you. And also the second is that there are several categories of products within the NAND flash storage market. So there are SSDs, there are USB drives. So till you don't serve that full portfolio, you cannot utilize your wafer adequately and smartly to be able to serve the full portfolio.
So that you can cut it in smartly so that
you can use it from a yield standpoint, also from capacity standpoint, and also from there are different grades of wafer, and how and which grade gets allocated to which product depends upon its usage, etc. So this is one main reason. Second, obviously, is that the industry never existed in India. So to build that confidence and to build that kind of scale for sourcing from India, and that's where we really appeal to the government to play a big role in that place, so that we can stop imports from all the other countries from where the product comes from, and it can be sourced within the country. Now there are companies available who can package it, and I'm not only talking about us and the memory domain itself, but there are several packaging companies coming up and several types of packages. And so as and when we all mature, definitely it can be sourced from within the country and can also be exported. So today, whatever memory we build, as we're moving along and with more and more addition of export customers, about 35 to 40% of our output is getting exported.
And then, so you're saying different types of packaging, right? So I'm guessing, does one OSAT do one type of semiconductor? So you guys specialize in memory? Is that how it works?
So usually most OSATs will settle on a few categories of products. Right? Somebody might settle on power, somebody may settle on logic, somebody may settle on, and also depending on the wafer. Like we only stick to silicon wafer. There might be plants who are specialized in silicon carbide or specialized in GaN wafer.
Yeah.
And then also we don't do any discretes. We only do non-discretes. So we do purely ICs. Now within that, we started out purely as, with the focus being memory, because that's what we had, that was our initial start when we got into packaging. But memory is an extremely volatile business, and therefore we are trying to balance it out with non-memory products as well. But even in non-memory, we are trying to focus on, core ICs. We are not looking at power semiconductors per se. We'll do power ICs, yes, but not very high-end power devices. And we are not looking at silicon carbide or gallium nitride kind of products.
Yeah, and anyways, that's a very small fraction of the market, right?
It's a niche, yes. It's growing very rapidly with the demand of power becoming, an extreme. You look at all types of ICs; they're all power guzzlers. So to reduce power consumption there, and also in terms of the next generation of products available in some terms of EVs, etc. Power is a pretty big issue. So there are people who are focusing on that side because that's the next generation also. But still, you're right, it represents a very small percentage of the overall market.
And how's the business doing right now? How large are we? What percentage? Like you said, a third is being exported, but in terms of numbers?
So extremely small. Let's say all the types of packages put together, memory, non-memory. We are probably doing about 200 to 250,000 pieces a week, because the non-memory is, they are low value products. So we are able to package about 500,000 to 1 million pieces a month. In terms of, we are extremely way below right now as compared to, let's say, competition from the Far East or other Southeast Asian nations. But I think we are confident that we're on the right track. As I said at the start, the gestation period is quite long. We have to focus on developing all types of packages. So we are now in the process of developing higher end or higher pin count QFN packages, QFP packages, which will have more value add in them as well. And so therefore we are also developing our teams to design lead frames, substrates all in-house, so that we can have more and more value add and local content. But I think this is the right path. We have engaged with customers overseas, and I think their patronage together with some of the large Indian product companies, if they have patronage for Indian packaged ICs, I think that will set the ball rolling for all of us.
And in terms of what's the next stage for the business, right? You've built this, and today, unfortunately, we only had time to look at the semiconductor business. It's a large conglomerate with EMS and other large multinational clients, right? So what's next for the entire group?
The core for our group is that we are an electronics outfit, right? Whatever we're doing, whether it is EMS, it is our PCB fabrication, it is our RFID business, it's all related to the core of being electronics. And if you look at all of these pieces of the business, they're all related but independent of each other. So we are definitely focusing more towards deep tech, right? EMS being at the front of the value chain. PCBs is backward integration, semiconductor is further backward integration. So we are trying to be part of the overall value chain so that we can continue to be relevant to our customers in the years and future to come. Also be able to build the entire electronics ecosystem for the country and to be able to position India in the global market. As the demand starts to grow, as we are seeing in India as of right now, there will be, and with the government policies which are extremely beneficial to the industry and towards Make in India, there is no doubt that there will be a lot more demand coming in. And with that, we want to be well positioned to be able to serve the industry. So a plant like this or a facility like this is being positioned for future, that as we continue to develop these solutions, and the entry barriers will become more and more difficult because we will also move towards stabilizing our standard packaging and then going into advanced packaging. And this is how everybody has done it over a period of time. Perhaps we might shorten that overall curve, but that's how we will also go in that direction. So having said that, the idea is to be relevant, be sustainable, build products together with the ecosystem within the country and be able to fulfill the India's electronics demand as well as the demand for the global customers.
No, today we are short on time, so maybe we'll pause today and then I will book you for our next season because semiconductor is such a fascinating space, and today we were only able to cover the process and the core part walk through, but I'm extremely keen to also understand your EMS business, right? Because that's a beast in itself, and that's where a lot of action has been. While semiconductor is just coming up and it's the future, the EMS is taking hold in India, so to speak. And I'm sure there are many challenges with that business.
Yes.
Right?
So
next time,
for next time,
we definitely sit down and look at the EMS business.
And hopefully next time there is a newer package that we've developed, and we'll be happy to show you that as well.
Brilliant. Thanks a lot,
Thank
Varun.
you. Thank you very much.